So the topic of our video today is real and ideal gases. What parameters do we use to describe gases? So we have three. This is the pressure, volume, and temperature. So for pressure, force over unit area, 1 atm is equals to 101 kPa. For volume, we have liters, and temperature, we have Kelvin. So table 9.1, composition of dry air at sea level. So constituent, then the percent of volume, then the percent of mass. What is meant by the percent volume? In principle, the actual molecular volume of a gas is small in comparison to the volume it will occupy that we treat gases at mathematical points. How do we measure pressure? So above 1 atmosphere, below 1 atmosphere. So here is the diagram. Gravitational force 1.00 meters squared. A column of air 1 meter squared has a mass of 10,300 kg, producing a pressure of 101 kPa due to gravity of 14.7 pounds per inch squared. 180 N is equals to 76 centimeter Hg, or 101 kPa. Boyle's law. Boyle's law is concerned with the relationship of pressure and volume using a fixed amount of gas, or a fixed number of moles of gas. P and V constant at constant temperature. Avogadro's law is concerned with the relationship between the number of molecules, or moles, or symbol of N, and the volume of a gas under conditions of constant pressure and temperature. V infinity N at constant pressure and temperature. Charles' law is concerned with the relationship of temperature and volume when dealing with the constant amount of gas. Moles of V infinity T and T is expressed in Kelvin. The K temperature scale is derived from behavior of gases. And then V is equals to KT, where K is constant temperature, constant pressure. Ideal gas law. So we have the formula PV is equals to nRT, where R is constant, and the value of R is 0.021 liter atm per Kelvin mole. Note that at constant N and T, PV is equals to constant. That is Boyle's law. And for Avogadro's law, P and T is constant. V over N is equals to constant. And constant P and N, V or all over T is equals to constant. That is Charles' law. Standard conditions of pressure and temperature. T is equals to 0 degrees Celsius, which is equal to 273 Kelvin. So pressure 1 atm. What volume does a mole of any gas occupy at STP? So we have the formula of PV is equals to nRT. So the question asking for a volume, so volume is equals to 1 mole times 0.0821 liter per atm per Kelvin per mole times 273 Kelvin all over 1 atm. So the volume is equal to 22.4 liters. This means that equal volumes of gases under identical conditions of temperature and pressure contain equal number of molecules. So here is the table. 9.4 molar volumes of some real gases at STP. So here's the question: what is the difference between ideal gas and real gas? The ideal gas equation was generated from kinetic theory of gases, making the following assumption. 1. The molecules could be treated as points. 2. There are no attractive interactions between molecules. 3. Gas particles move around on random. 4. Collision of gas molecules with the wall are totally elastic. 5. The kinetic energy of gas particles is infinity to temperature. In general, the ideal gas law works best at low temperature and high temperature. Real gases. Van der Waals equation. So here's the equation: P plus an squared over v squared times v minus nb is equal to nRT, where an squared over v squared connects for intermolecular attractions and nb corrects for real volume of molecules. Dalton's law of partial pressures. So it is the same as the other one. Total loss pressure is 1 atm. How much of the pressure is contributed by N? So pressure is consequence of molecules colliding with each other and the walls of the container. So for air, here's the equations. Constant T. So here's the formulas. Since the actual volume of the molecules is small in comparison to the volume occupied by the gas, all molecules occupied the same volume V. The contribution to the total pressure is independent on the number of collisions of each gas with wall, and this is dependent on the number of molecules of gas. Hence, P is equals to P and 2 plus P02 and so on. Temperature, a measure of average kinetic energy of molecules. So the graph of table 9 provides average speed of some molecules at 25 degrees Celsius. So that's the speed of which the temperature is at 20 degrees Celsius. Distribution of molecular speed as a function of temperature. Percent of molecule, yes, that's it. The speed. Two molecules of different mass at the same time at the same temperature if using through an opening. Two molecules of different mass at the same temperature if using through an opening. So here's the other one and that's the other one. So as you can see, it is lesser than the other side. From the kinetic theory of gases, speed of molecules, U is equal to 3 RT over m raised to 1/2 for gases at the same temperature. So that's the equation. The rate at which molecule hits the pinhole if the comparisons are made the same concentration of temperature. Solving some problems involving gases. A sample of gas at 25 degrees Celsius and 2 atm pressure in a 5-liter vessel was found to have a mass of 18 grams. What is molecular weight? PV is equal to nRT, so this we have 2 atmosphere times 5 liters is equals to n times 0.0821 times 298 Kelvin. So MW is equal to 44 gram per mole. So here's the example of the equation. So P is equal to 1 atm. Suppose the gas at the right exerted at pressure of 15 cm as shown would be Would the pressure of the gas be greater or less than 1 atm? How many atm of pressure is the gas exerting? So 1 atm is equal to 76 centimeter. 76 minus 15.2 is equal to 60.8. Suppose we have a sample of equal amounts of H2 and D2 in the vessel and a small opening is introduced. What will be initial rate of effusion? UH2 over UD2 is equals to MD2 all over MH2 is equals to 4 over 2 raised to 0.5 is equals to 1.42. So will be relative change with time. What is the density of natural gas? CH14 at STP. So formula PV over nRT density is equal to G gram over milliliter or gram. We know a molar volume of gas is 22.4 liter at STP. How many grams of methane mole? So that's the equation and the answer. The surface temperature of Venus is about 1050 K and the pressure is about 75 Earth atmospheres. Assuming these conditions represents a Venusian STP, what is the standard molar volume of the gas in Venus? So gas in Venus, so we have the formula 75 atm times V over 1. So V is equals to 1.15 liters. Natural gas mixture of constant including methane. If the total pressure of gas is 1.5 atm, calculate the actual pressure contributed by the gas distributed. So that's how you solve the equation. Mole fraction is equals to mole A times over mole A plus mole B and so on. That's all.